See, we are going to discuss today few fundamentals. So one more thing we have left, that is 3D printing and rapid prototyping technique. So before this, discussing this particular sixth technique in which is included in our syllabus. So I would like to discuss some basics regarding this RP technique or additive manufacturing. See, many of you has gone through the CATIA modeling software. So what is may I know the definite abbreviation of CATIA? Anyone? Hello?
Computer-aided three-dimensional interactive applications.
Okay, right. This is basically why we are going to use CATIA in, why we are not going for Creo software or some other softwares. Anyone, please? Why we exclusively this CATIA is meant as a product development cycle? Why this particular software is used? Any one of you?
For designing purpose, it can make use easily. We can use.
Not for other any other answers from you? Any other answers from you?
Sir, in the software analysis also there, sir.
Analysis? No, maybe not. It may be now. It may be included. I don't latest version about this, but it is meant for modeling. It is purely meant for modeling software. I have not received the exact answers, but basically I will give the clarification about this. So this is meant for surface modeling, which is meant for surface modeling, and whereas Creo is meant for the large assembly sections. We can also create solid modelings in the CATIA, but for surface modeling, it is best suitable software. Whereas in the aerospace or in the surface modeling has the major role in aerospace applications. And Creo is that is the difference why we are going to use Creo in the assembly sections. And what is the company? May I know the company which has initiated this CATIA software? Anyone? Company?
Dassault, sir.
Dassault. Creo. That is Creo or Creo. Creo or Creo softwares are developed by company. Please. No answers from you. So it is the PTC company. Company name is PTC. Okay. So Unique Graphics. I think nowadays we are calling it NX software. That is Siemens NX software. Siemens NX software. So it was owned by Siemens now. Okay. So there also we are going to produce the product analysis. We can perform both analysis and I'd like to discuss some what are the formats required in the product. If you are going to model a component, then for analysis So to transfer into analysis, what kind of formats required to transfer that files? Modeling file. How to transfer modeling file? What is the format required? Anyone? Hello? 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 Have you heard a word IGES? IGES. Any one of you? Please respond. IGES. Initial Graphics Exchange Specification. Initial, note down this abbreviation. Initial Graphics Exchange Specification. So this is the format to transfer geometrical data and CAD models. So it is used to represent boundary representation and construct solid modeling geometries. So both the boundary representations and construct solid geometries we are going to transfer, change, initial graphics through initial graphics exchange specification. And I'm going to have one more file, that is file format, that is step file, STEP. Note down this also, step file. Abbreviation is standard for the exchange of product model data. Standard for the exchange of product model data. So this is also a format. So it is used to share the 3D models. So it can be used many of the modeling softwares. Okay, but so you may have the doubt, what is the why we have to use the IGS file, or why we are going to use the step file. So note down this difference also. In IGS, the output surfaces are step file. Keep the assembly. Hello. IGS output in surfaces, whereas step file is mixture of solid and volumes and surfaces. So step file, it has the advantage, whereas IGS file format is suitable for surface models. Note down these points also. IGS file format is suitable for surface models, whereas the step file is suitable for STEP. Step file is suitable for mixture of solid and surfaces. Okay, these are the fundamental differences. And step file, many a times I discussed about the STL file. What is STL file? స్క్రీన్ పెట్టలేదండి, నేను మొబైల్ నుంచి చెప్తున్నాను. ఐఎమ్ డిస్కసింగ్ ఇన్ మొబైల్. జస్ట్
మొబైల్ నుంచి కూడా షేర్ చేయొచ్చు స్క్రీన్.
సార్ ఆప్షన్ ఉంటుంది సార్ అట్లా.
having there is a option screen, share screen, but that this particular it is not a so note down few points about this STL file. STL file is widely used because it is simple, light, and easy to handle by 3D machines and softwares. Easy to handle by the 3D machines, 3D printing machines. So this format uses a series of linked triangles. Note down these points also. This format uses a series of linked triangles to recreate and reproduce surface geometry of the 3D model. Surface geometry of the 3D models. The triangles used, the higher resolution of the models will have. So the particular models which we are going to generate this through particular this format, we are having high resolution. But in the same manner, we are having some limitations also. Note down the limitations of STL file. STL file. So it only understands external surface and shape of the 3D model. STL file only understands external surface and shape of the 3D models. Are you noting the points? Hello? 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 Participants, are you able to note the points? External surface and shape of the 3D models. Please note the points. So another biggest problem is gaps and overlaps of the joining surfaces. So overlapping issue. Overlapping of joining surfaces. And
Sir,
gaps.
share screen.
Entandi? Hello?
Screen share అవ్వట్లేదు సార్.
I know it. I already discussed this point. It is in PPT format. I have not converted in PDF format. So I am unable to transfer the file now, right now. I will share with you in WhatsApp. Don't worry. But a few points, please note down now. Having some power issue today. So next, export. So that is the problem for the STL file. That is limitations of the STL file. And these are known as non-manifold edges. Non-manifold edges. So these particular formats, so we can use for the surface modeling, surface form modeling. So exporting STL files using 3D, exporting STL files using different CAD softwares. By using SLA technique, by using a LAM and the SLS, select to laser centering technique. So using every technique, we are going to adapt the 3D printing, 3D printing. So see, as here the metal is, as we discussed in the last classes, the fusion deposition modeling. Here two-dimensional view is given. 3D. Also, we have seen a video lecture in the last session. So here the metal is depositing through nozzles. Through nozzles, a metal is extruded through nozzles. Say build platforms and reduced parts, layer by layer, reduced parts are framed and complete. Finally, you are going to get the final product output. Sir, next slide. Okay, sir, it is completed. Fusion deposition modeling completed. select. So stereolithography. It is also, this is the first technique by laser. Laser is a working principle. By laser as a setup. We are going to focus on the liquid designs. So next, go through the applications directly. All these processes are completed. All these processes are completed in class, sir. Please go through the applications. Next, yes. See, for a face mask is printing today. In every museums or some hospitality sector, we are going to use the many prototypes with plastic fibers, as well as a smooth rubber type of materials. So which is having elastic nature, plastic which is having elastic nature. So some kind of alloys also, I mean composites, we are going to we are going to use as a materials, and we are going to fabricate these particular shapes. So next slide, please. See, tourism, which is developed by 3D printing itself, models, ports, and it is the car interiors, tires, everything, whatnot, everything which is going to be developed by 3D printing machines. So it is helmets which are prepared. So I said in the last sessions, we are having helmets which are used for the normal vehicle riders, and helmets which are used by the industrial purpose, helmets which are used for the army persons. So we need to test wind tunnel testing. We are having in our thermal engineering laboratory, we are having wind tunnel testing. So in that particular machine, we are going to test after manufacturing by 3D printing machine. We are going to test. Testing will be different. So it is previously it is these particular helmets are fabricated through subtractive manufacturing. So now we are going to implement additive manufacturing, that is depositing the material. So no wastage of the material in this particular manufacturing process. Next, sir, please. It is also so it is sir, previous slide, please. Say one kind of axles and wheels are placed. A suspension system is placed. Axles and wheels with some couplings. Suspension system also placed at both the ends. So this is I think automobile prototype. One of the recent automobile prototypes. Next, sir, please. So patterns, different patterns for casting, produced by 3D printing process. Sir, next. Molds, which is previously we have used some wooden molds or some metallic molds. Which is used as a mold for molds. Now with these particular products, molds are prepared by 3D printing itself. So in industry, we are going to have this particular casting, die casting. Die casting, we have rapidly, frequently we are going to change the molds. In injection molding, die casting, this particular manufacturing process, we are going to use the different shapes and with the different contours. With the different contours, we are going to produce different products. With using polymer as a material, we are going to in injection molding and die casting especially. So next, please. So these are the ornaments. See, ornaments with 3D printing. Ornaments which are produced by 3D printing process. So these are the simple models. Gear, some type of wheels, some type of different models. Customized models. direct tooling. So tools which are used in. So we will discuss later about this tooling, all these things. We are having another chapter for this tooling, I mean rapid tooling. Sir, please next. See, after creating the CAD models using Kitty or whatever, maybe using NX by Siemens, whatever maybe the modeling software, we are going to model first, and next the same products which are fabricated using 3D printing, whatever may be the technique. Technique is differs with some parameters. What are the parameters which are affecting the the speed of the product manufacturing. The speed of the product manufacturing. Sometimes we may have material limitations. In some machining process or some manufacturing process, we are having material limitations. We can't adapt all materials in all machining process. The specific material is are used in the specific machining process, whatever may be SLS, whatever may be LOM, FTM. So composites, sometimes we may produce, sometimes we will go for the metal components, we will go for the polymer as the materials. So depends upon material customization also, we are changing the working process or working machinery process. So next please. So it is reverse engineering. So skull of the human body, it is printed by 3D printing machine. So they will take these particular data inputs taken from the MRI scans or CT scans, computerized tumor scanning. So from that, the geometrical data is taken by the designers as the input data. Then they are going to deposit material as per the model. Model has been created from the reverse engineering, not from the concept, Actually, previously it is generated from the actual concept. So now, recently, I mean, reverse engineering also plays a key role, especially in the biomedical applications or biomedical field. Biocontact. So these materials have to be, we have to take care. Biocompatible compatible materials. Biocompatible materials. That means it should not affect the other organs. It must compatible with the other organs in our human body. So materials also we have to take care while fabricating or manufacturing a human organs or human implants. So next, see, medical implants. These are the medical implants, various medical implants. Sir, previous slide, please. So arm, spinal cord. So nowadays, backbone, I mean spinal cords, they are manufacturing. Dental field. So trending manufacturing process today. 3D printing. Next slide. See some of the few fingers. I mean one. Biomedical applications. So materials which are used, materials for 3D printing. So these are the plain carbon steel, PCS steel. So they based on their material properties. Material properties also we have to suggest in the process or working principle. We have to suggest in working principle. So titanium, bronze, nickel, and aluminum. These are the different metallic materials. So please, polymers and polymeric composites. So as we discussed in the previous FDM technique, ABS plastic, butadiene styrene, acetone, butadiene styrene is the material, and here polycarbonate and PP is some type of epoxies. Next, glassy polyamide. These are the polymer family. This belongs to polymer family. So next, the other materials which are recently, previously only it is limited to plastic materials or polymer materials. Nowadays, by using 3D printing process, we are going to fabricate all kinds of materials. That is ceramics, even ceramics, tungsten, wax, starch, everything. So especially these particular biomedical applications, we are using starch as the material sometimes in some applications. Natural fiber reinforcement composites, NFRC, we call it as NFRC, NFRC composites, natural fiber reinforcement composites. If you see below, there are different poly polymer family LC, which is biocompatible. Second title, polymers and polymeric composite, is different from this. This is by compatible with the human organs. They are going to the, so in the recent research work there in biomedical applications, they are going to use these particular materials. So next, please. So what is the limitations? So as we discussed, the cost, we can't, we will go for especially prototypes. Whereas once prototype has been developed, our working methodology is rapid prototyping is different from additive manufacturing. So additive manufacturing, we are having functional goods, direct functional goods. But most of the times, rapid prototyping is adapted for prototypes, only prototypes. Why? Because the initial cost will be high. Next, accuracy levels finish, surface finish. We are finishing it, surface finish, and strength parameters and the material options. So these are the limitations. So next. Okay, now I have sent another PPT, sir. Please STL PPT. Please open that mail, that first mail. Sir, hello. I have sent 2 mails to you. Participants, I am unmuting all. Can you respond? So 3D printing. Sir, I will conclude today, sir. Okay, there is some problem. So tomorrow we will going to discuss about 3D printing in detail. Okay, I am ending this session for today.